The following is the video solution from JSDT Solutions. Question 6 says, in the diagram below, the graphs f of x, which is equal to that, and g, a straight line, are drawn. So we have a parabola and a straight line. C, which is 3 and 8, is a point of intersection of f and g, as we can see. EH is drawn parallel to the y-axis. So it is a vertical line with E a point on F and H a point on G. And the first question asks us 6.1 to calculate the coordinates of B, the turning point of F. So find the turning point, which is this. You can see that they gave us our equation in standard form. So when finding the turning point in standard form, we use this equation. So this will find the x value. X equals negative b over 2a, and we're going to substitute our b and our a value. So that is going to be, as you can see, a is negative 1 and b is 4. So x equals negative and then 4 over 2 times negative 1, which means they're both negative. So that's just 4 divided by 2, which is 2. Okay, so we have the x value, and now we can find the y value by simply substituting that x value into the equation. So f of 2 is equal to, and we'll have negative 2 squared, so negative 2 all squared plus 4 times 2 plus 5. And therefore f of 2 is going to be equal to, these two together give you 8 and 5, that's 13, minus 4, 13 minus 4 is 9. So that is our answer over there. So B is 2 and 9. And that is the answer to that question. Question 6.2 says, show that the equation of the line through A and C is given by g of x equals 2x plus 2. Okay, so through A and C. You can see that if it goes through A and C, we just need these 2 points to find the equation. So A is missing. And as you can see, A is also the x-intercept, one of the x-intercepts of the parabola. And at the x-intercept, you know that y is simply equal to 0. So let's go ahead and do that. This is the equation of the parabola, and we'll set it equal to 0. Okay, at this point, you can multiply both hand sides by negative 1 to get that to become positive, or just bring them over. So we have x squared minus 4x minus 5 equals 0. And now we factorize. So equal to 0, x multiplied by x gives you x squared, and factors of 5, that can give you a 4. Okay, factors of a negative 5. 5 is a prime number, so it's just 5 and 1. And which should be negative so that we get a negative 4 in the middle. It should be the 5. Give the negative to the bigger number. Okay, so this is x is equal to 5 or x is equal to negative 1. So now we can choose. Which would it be? This is A and this is D. They're both x-intercepts. So it's clearly the negative 1 that we're going to use here. And then that would be the 5. Okay, so this is finally A is negative 1 and 0. And now we can use this to find the equation. So we know what C is. C was 3 and 8. And we can just find the equation of this graph now. So it is a straight line, meaning we need to find the gradient first. So gradient and then the formula for gradient. When subtracting, just make sure you are consistent. If you're going to say top minus bottom, you need to do the same thing with the x values as well. So this is going to be the gradient of AC is 0 minus 8, top minus bottom, over negative 1 minus 3. We know that 0 minus 8 is negative 8, and that gives you negative 4. So negative 8 over negative 4 is positive 2. So that is our gradient. And now we just have to find C. So you can use y equals mx plus c, or use this equation. So we'll say y minus y1 equals gradient times x. But we already know what the gradient is. It's 2. So times x minus x1. And then substitute a point. Choose the easier point. So I'll take A. So this is going to be the x1. That is the y1. So this is y minus 0 equals 2 times x minus negative 1, which of course multiplies and gives you a positive 1. So y minus 0 is y is equal to, and then distribute, it's 2x plus 2. So that is g of x. G of x is simply equal to 2x plus 2. And that is our answer. Question 6.3 says, calculate the maximum length of EH for where f is greater than g. Okay, so in our graph, the length of EH where f is greater than g, do you see that E lies on f? Okay, so that represents f. And then H lies on G. So where f is greater than g, so that just means that the y value of f is going to be greater than the y value of g for EH when we want to find the length of EH. Okay, so you're simply going to say f of x minus g of x. Take that y value minus this y value, and it will give you the length of EH. Of course, this will be in terms of x at first. Okay, so we're taking the graph of f and subtracting by the graph of g. So to find EH, we say f of x minus g of x, and we're going to say this is equal to, and we have negative x squared, all of that, minus the g graph. But remember that this is going to be put in brackets, so it'll be 2x plus 2, and if you distribute, they become negative 2x minus 2. So this is equal to, and now just put your like terms together. So those two, they give you positive 2x, and 5 minus 2 is positive 3. Okay, so this is the length of EH. It's not the maximum yet, it's just the length. So now to find the maximum, do you see that the length of EH is in the form of a parabola, a concave down parabola specifically? To find the length, all of these, right, at different points, it's going to tell you the length of EH at different x values. But we're looking for the highest, the maximum, which happens right here. And we know that this point is the turning point. So all we have to do is find out exactly what is the y value of the turning point, because they want the maximum length. They don't just want the x value at which it's a maximum. Okay, so let's go ahead and do that. So in this one, you can decide to still use x equals negative b over 2a, or you could derive, and that's perfectly fine. So I'm going to derive. If you derive that, and again, you're going to derive it and set it equal to 0, because at the turning point, your gradient is 0. So to find the gradient, you derive the function. So deriving that, it will be negative 2x, coefficient times exponent, exponent minus 1, and plus 2. And we'll set that equal to 0. Okay, so since this is going to be positive, if we take it over, you might as well say 2x equals positive 2. And then if you divide both hand sides by 2, x is therefore equal to 1. So we now know the x value at which it's the maximum. We have to take that and substitute it into the equation of EH so it can find out the actual length, the actual maximum length. So the maximum of this is going to be negative, and we'll say 1 all squared plus 2 times 1 plus 3. Okay, so this is equal to, and these together give you 5. 5 minus 1 is 4. And we can just conclude the maximum length of EH is 4 units. And that is the answer to that question. 6.4 says, given k of x is equal to f of x plus m. Okay, so a translation is happening here. So you can see that it's affecting x, meaning it is a translation either to the left or the right. Here's the thing. If you have a point or even a graph, and let's just say this point is 1 and 2, right? If you're adding or subtracting to the x, do you see that if I added to the x value over here, that this point will either move to the right or to the left? Okay, so adding to the x moves the graph to the right or left. But after that translation, it's equal to all of this. And they want us to determine the value of m such that g is a tangent to k. Okay, so the graph of f gets translated and it becomes k. And we need to find out the value of m for which g will be a tangent to k. Let's visually understand what's going on. We knew that the graph of f was a concave down parabola, and the graph of g was a straight line, an increasing straight line. And what they're saying is the graph of f is going to be shifted, either to the left or the right, but then it gets shifted in a way that it is a tangent to g. Okay, so we can just look at the possible ways it could be shifted so that it's a tangent to g. So if this is what the graph looks like, and it was here. Let's try shifting it to the left. You see what happens here? If you shift it to the left, at no point does it ever become a tangent. It's not a tangent over there. Tangents do not intersect lines. They kind of like graze the line. If you have a curve, circle, any type of curve, and you have a tangent, it does not intersect. It simply just touches one point briefly and then exits. That's really what it does. And at that point, the gradients will be exactly the same. Just like we can see, this parabola is decreasing here, then it hits a turning point, and then it starts increasing. In the same way, this graph is an increasing function. So at some point, the gradient is exactly the same. Okay, so with that being said, you can see that it will never be a tangent to the graph of k, the new graph, if we shift it to the left. This is never going to happen. It just constantly intersects the graph of k. Okay, so we're not going to shift it to the left. We will shift it to the right. Look at what happens when we shift it to the right. As we shift it, eventually it sits like that and it will intersect the graph of g. Okay, so there it's just briefly passing it. So this would be k, meaning it's going to shift to the right, and then we can see what that is. Okay, we'll just keep this visual on the side just in case we'll need it to, understand anything. So this is what we end up with. Clearly, we're going to have to deal with more of the algebra of this because it's 5 marks and they wouldn't give you all of this for nothing. So let's see, how can we make this possible? How can we ensure that G becomes a tangent to K? Okay, let's just look at a few things. You see, if it is a tangent, the first thing that we'll see is that it intersects with the graph of G, meaning at some point K of X will be equal to G of X. But now what we can do is take advantage of the fact that this forms an equation and it's going to be a quadratic equation since K is quadratic, okay? K is quadratic because it's a shift from F, which was already a parabola. So we can manipulate the amount of intersections it will have by manipulating the discriminant. So here's what we can do. Because they intersect, we can ensure that the discriminant, okay, b squared minus 4ac is equal to 0. Here's the thing about the discriminant. With a parabola, you know that if the discriminant is greater than 0, you will have two unequal roots. So this is something like x minus 1 and x plus 3, for example, right? Two unequal roots. But if you make delta equal to 0, what actually happens is you're getting equal roots. So it's something like x minus 1 and x minus 1. And do you see that these are actually the exact same numbers? So you end up with one root. And that's what we're trying to do. We're going to equate these two graphs and then ensure that the discriminant is equal to 0. And that would ensure that they intersect at one point only. Okay, so let's do that. We're going to focus on finding k of x being equal to g of x. Let's simplify that. So k of x, we already know what that is. It's all of this. So we'll make it equal to g of x. And we know that g of x was 2x plus 2. So all of this again will be rewritten, and then we're going to take g of x over, these over. So they will come over and become minus 2x minus 2 is equal to 0. And let's just put our like terms together now. So negative x squared, and these two go together, becoming a positive 2x. You might as well write this with this because do you see that it just has a coefficient, but the variable that we have is x. So we're going to put them together because they will still be like terms even if they can't add right now. So we have minus 2mx, that's done. And then the constant, because that's all that's left. So that would be your negative m squared, and then your plus 4m, and 5 minus 2 is positive 3 is equal to 0. And this is what we have. Now this equation, all we have to do in this equation is ensure that the discriminant is equal to 0. Okay, how do we find the discriminant? The discriminant is, remember, that part of the quadratic formula that says b squared minus 4ac. We'll make that equal to 0. But of course, for us to do that, we need to be able to see b, a, and c. Right now, a is clear. It's the coefficient of x squared. Here's x squared. It's the only x squared. the coefficient is clearly -1. But here, it's not easy to see yet. So let's just make some adjustments to that. Here's what we can do there. We leave this as -x squared. And then with this, because they both have x, it's like taking out x as a common factor. You could write it like this, x, and say what is left here, you're going to have 2, and then minus 2m. So this now becomes the coefficient of x, which is b. Okay, and then the constant is just everything that does not have x in it, which would be all of this. So that's minus m squared plus 4m plus 3, and then we have is equal to 0. So we know what a is, we know what b is, and we know what c is. We can substitute it and find out what this will be. So this is where b squared, which is 2 minus 2m, so 2 minus 2m, all squared should be, and then minus 4a, which is -1, and then c, which is -m squared, plus 4m plus 3 is equal to 0. And now we can simplify this. So this is going to be 2 all squared, which is 4, -2 all squared, which is positive 4m squared. And then 2 times -2m is -4m, but you multiply that by 2, giving you -8m. And here, when we multiply these two together, they give you a positive 4. And that's going to distribute into here. So it's 4 times -m squared, which is -4m squared, 4 times positive 4m, which is positive 16m, and 4 times 3, which is positive 12, is equal to 0. Okay, so this is what we have. Okay, great. Do you see how 4m squared and 4m squared would cancel? And all you're left with here is the -8m and 16. 16 minus 8 is 8. So that's 8m. And we have 4 plus 12, which is 16. So plus 16 equals 0. And then you can take that over. So 8m equals -16. And divide both hand sides by 8. Therefore, m is finally equal to -2. And that is our answer. M should be equal to -2 so that G is a tangent to K.